So I would like to extend a warm welcome to everyone today to this fourth Diginomic research talk. And it is a great pleasure, first of all, on the one side, to co-organize the event again with the BREMEN.AI data launch, and also for the first time to co-organize it with the Data Science Center of the University of Bremen. I think this is always a great fun to bring practitioners and academics together and to talk about AI. Today we have Dr. Michael Engel from the Volkswagen Financial Services, who will talk about AI product management. And we have around 100 people signed up for today's talk. So apparently this was really a topic that people have been interested in. And before we start, I would like to briefly introduce to you the Diginomics Research Group, and then Lena and Sven will also introduce BREMEN.AI and the Data Science Center to you. And just that you know what our group is all about. And from our side, Diginomics, we are currently consisting of 15 professors and 4 postdocs and senior researchers or lecturers, as well as more than 20 doctoral students who are all working together on various aspects of digitalization and topics related to digitalization in business and society. So that is our focus. We are not so much into most of the technical details. We are more interested how digitalization, AI, and so on are affecting society and businesses. Research areas we are working on are work 4.0, as we call it in Germany, the blockchain technology, cloud logistics, digital finance or fintech, digital harbors, AI, the digitalization of production processes, and platform economics. And every Wednesday, we organize a Diginomics lunchtime seminar, as I mentioned before, at which outstanding academics from all around the world present their research. And the next very, very prestigious talk we have is January 20th, where at 4 p.m. from the West Coast, Professor Dr. Markus Pelger from Stanford University will talk about deep learning and asset pricing. The Diginomics Research Group also organizes a speaker series where we are today, the Diginomic Research Talks, which usually take place in downtown Bremen. But due to the COVID crisis, we are doing this now also digital. And the goal is to establish a discussion between academics and practitioners. And we are mostly focusing on topics practitioners and academics are both interested in. So ideally, this connects people within Bremen, but if renowned speakers from Volkswagen Financial Services come to us, we are always happy to have people from outside, even though we also have a large production site for cars here in the region. And so this is from Diginomics, and I would say I hand over to Sven and Lena.
Yeah, thank you very much, Lars. It's a real pleasure. Also a warm welcome from the BREMEN.AI side today, from the BREMEN.AI data launch. My name is Sven, and I'm currently a data science consultant at InfoMotion, and I'm also the founder and the host of the BREMEN.AI data launch. For those of you that do not know BREMEN.AI in particular, it is the official cluster of artificial intelligence here in Bremen, and its main goal is basically to connect academia with the industry. As you just said, Lars, connecting industry and academia is very important, and it does so. The BREMEN.AI does so with some main events that are basically around 150 or 200 people, but also with specialized events. For example, the data launch meetup, and we are focusing on specific topics. For example, the data launch is focusing on data science and machine learning from A to Z. So really the whole machine learning life cycle, and this includes data and ML ops, this includes modeling, this includes data visualization, but this includes also data strategy and data and machine learning management. So I'm very excited for this talk today, as we have also the second part, I think, of this mini series, the cooperation between the BREMEN.AI data launch and the Diginomics group. and it has been a pleasure so far. So I'm really excited for this talk, and I may now hand over to Lena as well.
Yeah, thank you, Sven, and thank you all for being here. I'm really happy to see so many, well, squares in this case, but see so many people being interested in that topic. Yeah, my name is Lena Steinmann. I'm the coordinator of the Data Science Center, which is an interdisciplinary institute at the University of Bremen. Our spokesperson is Rolf Drexler, and well, we are basically the focal point at the University of Bremen for data science. So we bring together scientists from all faculties to advance to their data science methods, to develop new teaching concepts, and eventually to bring all of that into application. And simply put, our goal is to provide scientists from all disciplines with the right tools to be able to effectively analyze their data, extract information, and eventually transform their data into value. If you want to learn more about us, you can just visit our website. You can find us on Google, Data Science Center Uni Bremen. And I'm always happy to exchange thoughts or ideas to start projects. We're also on Twitter. But yeah, now I'm looking forward to Michael Engel's talk, and I'm really curious to learn more. So thank you.
Okay, yeah, so it's my great pleasure that we have Michael Engel here today. And to be honest, this is really a coincidence. Michael and I worked at the same chair at LMU Munich a very long time ago. You might not believe it, but this is, I think, already a decade ago or even longer. And we didn't meet, even though we worked at the same chair, or at least I did my PhD over there. And then at one time we met in the train. So it was just by coincidence, a guy was sitting in the train, and then we talked to each other about a book that was laying on the table. And then we realized that we actually worked on the same chair and never met each other. So, and we keep bumping into each other, and we have met in very far distant places such as Trier, Munich, and Bremen by now. And it was really a pleasure to see that Michael is now the head of data and AI product management at Volkswagen Financial Services. And he also manages a portfolio of innovative applications of data science and machine learnings for mobile services and automotive finance. So I think this is really a topic that is becoming more and more important these days. And so I'm really curious what he has to talk about. Before joining Volkswagen, he worked as a data strategy consultant at Deloitte Analytics Institute. And he also holds a PhD in economics, which can never hurt, I believe, and is often a speaker and guest lecturer on information systems and applied machine learnings. So we are very happy to have him here and to hear what he has to talk about AI product management. And without further ado, Michael, the floor is yours, and I'm very much looking forward to your talk.
Okay, thanks. So I'm sharing now. Thank you for the welcome, and I'm looking forward to share my knowledge about AI product management from my practical perspective. So let me start. What is this talk about, or what do I try to achieve? We are all, I think it's not controversial that people see tremendous potential in machine learning and artificial intelligence and their applications. So I think this is not problematic to make the statement. On the other hand, few companies could really achieve deployments of these technologies that lead to tangible value. So this might be companies like Amazon and Google that are digital natives and even leading in research in these fields, but let's say some typical German company that is still in its ongoing digital transformation. The list of super successful, high impact deployments is rather short. I think I hope I'm not saying something wrong now. And I believe that one way to to move forward is to adopt the tools set and frameworks from product management. Product management is also not new. It's a business role. It's a function most dominantly known from software companies, and my claim is that we can use it to help to solve this challenge of creating tangible value from AI in more or less normal or not totally digital companies. Maybe I can skip over that. I was already introduced by Lars. I can say a couple of words about VWFS, or Volkswagen Financial Services, my current employer. This company is an automotive finance company, so the core business is to provide leasing contracts and financing for vehicles. So that's the core thing, and we offer that for almost all Volkswagen Group brands, so also Audi and Seat and Skoda and so on and so forth. Nevertheless, we also engage in some mobility services, especially those that are related to payments. So parking ticket payments, fueling payments, or charging payments, and so on. This is also a field we are active in, and where we also apply machine learning. Yeah, my own, let's say, if I have some credibility in doing data analysis, I gained it through my period as a researcher. So I was an empirical innovation entrepreneurship researcher, and that was the time in my life where I got the hands dirty with struggling with messy data and try to find something that is useful in there. Okay, but let's continue a bit with my role, because it's so directly connected to the topic of the talk. So we in Volkswagen Financial Services is a huge group within the group. So there's about 40 markets we are active in. But in the global headquarters, there is a specific team looking only at data analytics and AI. So it's the group-wide center for these topics. And within this group, we have 3 capabilities, so 3 skill groups. And the core of it, of course, is the data scientists or the data science chapter, mostly mathematics and physics guys that do the number crunching. And also equally important, the engineering chapter that is responsible for data pipelines, platform development, and say deploying and scaling the stuff. However, we also have this an own chapter, a dedicated chapter of people, so 10 of about 30 people that do product management for machine learning and AI. And I think that was a good decision when the unit was set up, because it's quite a difficult question to ask what to do with these technologies, while it is so appealing to dive into building the things right. So there are so many mathematical questions and technical questions you can ask around machine learning, but it's equally important, or even more difficult, to find the right application fields for those methods. So the classical saying in product management is focus on building the right things rather than, or let's say, leave the question of how to build the things right to the experts from data science and data engineering. And yeah, so I'm the chapter lead for product management in this group, and yeah, let's see. So that's directly connected to my role this talk. As a last information during the introductory phase of this talk, I would like to briefly familiarize with 2 use cases we are working on. So on the left side, you see the topic of parking availability prediction. That is, let's say, a subsidiary of ours is called Pay by Phone. They have a mobile app. You can download it from the App Store. And its original purpose is to make parking ticket payments, so you don't have to walk to the machine and search for coins or something. And now we are enhancing this product with a machine learning service that predicts availability of parking spots given the transactional data. So this is one application we have out there, we have live, and that we are continuously improving. On the right side, you will see the more classical application of data and machine learning in our company. As we are doing leasing contracts, it is key to know and to predict the asset value. So what you can see here is a typical leasing contract has a certain period, for example, 3 years, and the leasing contract states a prediction, what will be the residual value? So what will be the value of the used car at the end of the 3 years? And the better we can predict this value, the fairer is the price and the lower is the risk, and so on and so forth. So this is a prediction type the company does for many years, but of course there are new possibilities arising with the advent of machine learning. So here we are active as a second example in a core classical process that we are enhancing and improving with machine learning capabilities. Okay, let's head to the core of the talk. I structure this talk in 4 areas or 4 activity groups. The structure is quite simple. So what is common in product management is that you make a sharp cut between methods you use during ideation and coming up with new products, so the more or less innovation process, from activities that you should do after successfully launching a product. So maintaining and growing it is a totally different set of activities. So it's important to split the two and to look at them in the right order. The other distinction is also quite simple. So there are activities we can do to increase the return or the expected return of what we are doing. And on the other hand, so the lower row corresponds to reducing the risk so that this value will go away or will not materialize that we anticipate. And then it's a simple thing to derive this 4 topics and activity types that I would like to use to structure this talk. And I will now start with the maybe most difficult and the part that will consume most of the time is the ideation. So how can we come up with ideas for high impact AI products? So let's start to the first part. Ideation. Use this symbolic picture of post-its on the wall that is maybe familiar to all people that have taken part in any kind of design thinking or ideation project. So let's start to understand, let's discuss a definition of AI product so that we can find a way into this topic. And here's one definition. It's from a O'Reilly blog post, not super formal, but let me read it out. So AI products are automated systems that collect and learn from data to make user-facing decisions with machine learning. Now, what can we get from that? First of all, there's the classical trick. You start to talk about artificial intelligence and AI, but what you're actually talking about is machine learning. And that is why that's the classical maneuver, because no one is doing AI in the sense the research community talks about. But what we saw in the last years was this burst of machine learning techniques. And that's, I have to play the same trick. So what we are talking about in concrete applications we can develop in the next 1 or 2 years, we are most likely talking about machine learning deployments. The second thing is the only thing that narrows down what an AI product is the way, is the inner workings of it, is the way it creates value. and it's by collecting and learning from data. So it is, on the other hand, totally open where to apply it. So is it in a B2B, B2C setting, what kind of business function, everything is possible. And that is strange when you look from an innovation or product management perspective, because you could say we are in this situation. We have machine learning now as a hammer in search of nails, basically. So we have something like a solution approach, but look to the problem we could solve with it. And that's a bit funny and special, because if you have ever heard about good practices in innovation and design, you do it the other way around. So let's look at this picture. This is the well-known double diamond process from design thinking, where you strictly say, when you want to develop a new solution or new product, you start by exploring the problem space, but deeply understanding what is the problem people have, the customers you try to bring value to. Then you frame that well, and only then you start with diving into solution space. And then one of the solutions in the solution space might be machine learning. That's how you would do it if you follow a classical innovation and product management process. However, this doesn't work here. So we want to, let's say we have decided to look at machine learning, so we have to work the other way around. This is totally forbidden from an innovation perspective, but however, let's just do it, right? So don't care. Yeah, but it's an important thing to keep in mind. And to further dive into what this could be, I've created this slightly complicated looking slide here. I try to depict here what is the anatomy, the inner anatomy of a machine learning product, and I would say the core of it is basically something that maps inputs to outputs, so that it's a machine you can send requests again, you can send questions against it, and it will come up with more or less smart responses. And more or less at the core of any kind of AI product, you have such a thing. There might be layers around it that hide that, but this is always inside. And to further understand a bit what is so special about a machine learning product, we can look on the on the consumption side, on the left side. It's an input-output machine. Yeah, it's a question-answering machine, and you cannot distinguish it really from how it is made, how the mapping works between inputs and outputs. Only when you dive into the production side, like open the black box, you might notice that these mappings can come from different sources. And here, the classical distinction is that on top, we see the good old way. That is, we do explicit programming. So we think about the problem, we come up with a concept, like a logical or mathematical formula or whatever. We encode it, writing computer code in a program, and then deploy the program. So we totally grasp the problem, found a logical solution, and now answer the requests we get from the user. The difference when you look at a machine learning product is, where does this mapping come from? So you don't call it a program then, you call it a model maybe, or a policy. And it is created by taking data and plugging it into machine learning algorithms that then produce this mapping for you. And the role of the human is a bit different. So of course there's human effort involved, but we are overseeing this process. We are connecting some pieces. However, how the mapping looks like is created by the algorithm and is inferred by the algorithm from the data. And as a little spoiler maybe, when you think of what could be the bottleneck here, or what could be the critical input and resource, you see on top, it is human brain power, right? It's the power to conceive and logically grasp problems. On the lower side, it seems to be the data. Yeah, that might become here the bottleneck, or the critical resource. So now we have to distinguish when does it pay off? What characterizes request response mapping that should not be done in the good old explicit programming way? And one thing that points in that direction is the request type. So what was achieved in the last years is that we can ask these, we don't have to formalize our requests. We can send raw pictures, raw text, maybe even video and audio signals, and can get a classification back or a sentiment analysis of what is the mood of the text or what does the image show and so on and so forth. So the burden of pre-processing the data was taken away from us by machine learning, and we can now send more or less the data we have against this input-output machine. A bit more interesting might be now looking at the so the responses. And here I would like to make a bit of a theoretical distinction that I find very important and I see often confused out there in the business world. So we are now looking at the responses. So what is the thing we get out of the machine learning product? And there's basically two categories. It's prediction and prescription. When we look at prediction, which again would be maybe 80 or 90% of the products we will build, what we get there is an assertive message. That means it is a description or a classification that we can evaluate if it is true or accurate or false. And the example here is in a fraud detection case, for example, we send the machine a credit card transaction and it gives us back, I believe this transaction is fraudulent or not. So compare this to the right side, the prescriptive case, where the message we get back when we send this against is a directive thing. It's a recommendation or a command. And the evaluation of these commands are good or bad is done by tracking goal achievement or success or whatever. So it's not, if it is true or false, it doesn't make sense. It is clearly a valued thing that can be evaluated as good or bad. And when you look at the example here, it's about, so the machine learning product that helps you with fraud would say, do not process this credit card transaction. The machine blocks it and says, if we would process it then, or execute it, this would result in a loss. And that's why we are not doing it. And the latter, the prescriptive case, is of course much more complicated because we are heading in the direction of decision semi-automation or full automation that can lead to direct consequences, and the machine is allowed to act or at least make recommendation. While in the prediction case, we are only doing, let's say, decision support, but there's still another subsequent process that uses the prediction to inform an action. And let me add, all this can also be achieved by a handwritten program that is uses a heuristic, for example. It can do both. It can predict and it can prescribe actions. The only thing that might be different is the accuracy or the degree of success. So we are hoping for using a machine learning based prediction or prescription system to get more accurate or more accurate predictions or more successful prescriptions. I show another picture that hopefully makes it a bit clearer or maybe increases confusion. Let's see. So this is a picture of what some people call a data value chain, or something that tries to bring not true but simple enough logic into what we're doing. And when you read it from left to right, you would say that the source of all this value creation should be data, and what we can infer from data using the algorithm is some form of knowledge that is helpful when it helps us to act successfully and or choose the best action. And if we are choosing the best action, is to be evaluated by the outcomes we produce and how valuable they are. Yeah. So it's always centering around actions and the selection of actions or making decisions. The only question is are we informing an action with a prediction, that is decision support, or are we directly acting or directly recommending actions? That is then a prescriptive system. And in any case, we have to think backwards from value. And I have to say, so I have these 4 trigger questions here that you could use to link these responses to valuable things, is by asking, what outcomes are we trying to achieve in the real world that are valuable for us? And what actions can we take to affect the outcome? So when actions are not involved, not triggered by predictions or directly prescribed with a recommendation system, I doubt that at any point a machine learning product will translate into tangible real value. So it's the connection, or action is the centerpiece of the data value chain or AI value chain here. And yeah, okay, just to conclude, to finish the questions here. So what actions can we take? Do we have a set of effective actions? Only then we can deduce what knowledge do we need to inform our action selection or decisions, and how can we infer this knowledge from data? Okay. So let me move on and show this picture. What I see sometimes is that there is a problem or a product you could create using data and machine learning. However, it would be easier or faster to do it just by normal software or rule-based programming. So you can use the machine learning hammer to hammer in the screw here, but it might not be the best option. So the question is always, why not taking the screwdriver? Then another topic, I've manipulated a quote from Steve Jobs that everyone loves. So let's see if you also love it. Steve Jobs is, amongst various things, known for this quote that motivates people so much, is saying that it doesn't make sense to hire smart people and then tell them what to do. We hire smart people so they can tell us what to do. And everyone that is an employee loves Steve Jobs for this quote. And what it is about, I would say, is about a delegation. So you hand over the power to make decisions to your employees. And if you turn it around a bit and plug in machine learning systems or smart machines, then we get a flavor of how it feels when we give away the power of explicit programming to a machine that learns from data. So it would, I could claim, it doesn't make sense to build AI products and smart machines to tell them what to do. We build them so they can tell us what to do. And what I'm using this quote to motivate that we how it feels. So we must be willing to leave some control to these systems to gain value from them, and we must accept some uncertainty and opacity that is involved, because we do not longer exactly understand and explicitly write the rules, but we will be surprised by what the machine does. And but that's the only way. So if the machine only does what we want it to do, you could argue there's no value or no added value above the software. A last point I would like to make here is do not, what is a counter indication? When should you not invest in own AI product ideas or let's say problem solving? It is when someone else already did it and did it much better than you. And what you can see here is an overview of machine learning APIs that I think Google Cloud offers. So there are, whenever there's a general purpose task to be solved, it is likely that a big company already created a machine learning product for you. So label detection is detecting that this first picture shows what is it? Is it is this big white cat? Yeah.
A leopard.
A leopard? Okay. Yeah, I wasn't sure. This is solved. Also, face detection. I mean, every computer that has a photo organizing software has face detection built in. Also, what is not on this list here is translation, general text translation. So whenever there's a general purpose task that can be solved with machine learning, usually someone else already did it, and you will not invest in building it. You would rather buy it, I guess. So this is now a summary of my suggestion, like the heuristic to detect when does it, what are indications that you are after a high value AI product idea. The first is this complex mapping thing. So you want to establish a machine that can do something that cannot be solved with explicit rules, at least not in a more or less reasonable amount of time and effort. And the accuracy of the system is actually the bottleneck in the process. So of course you could squeeze out some percentage of accuracy in a predictive system, but it only pays off if it is the bottleneck, if it's the decisive kind of uncertainty that leads to, for example, better actions. The second thing we have to assume here is that we are looking at an idea or a task that we can live with we have some error tolerance. We can live with some uncertainty of the results we will get, and some opacity. So this is this well-known black box phenomenon that machine learning brings with it. So we can live with that. It's okay. And maybe, or an alternative way is that if errors occur, they are not life-threatening, or at least we have a scalable way to deal with errors. So this is a counter-indication, for example, for autonomous driving, in which Volkswagen invests a lot of money, of course. But if you are, if this is not the killer application all the industry is looking at, I would start to look after applications and use cases that do not lead to catastrophic results if the machine does something wrong, right? So when you look at recommender systems of products, or some like movie recommendations, so if Netflix gets something wrong and shows you the wrong movie, no one dies, so it's okay, right? But still it provides a lot of value. And finally, there's this specificity. I'm in search for a better word, so if you have one, tell me after the talk or now. So I would claim, I think it only pays off if you start to invest in machine learning, to build it on your own, if it is really core to your business, to your value proposition, or to your other products. Otherwise, if it's more peripheral, or if it's a general purpose task, just buy it, okay? It will not pay off. Or it is your decisive strategy that you want to outperform the competition in predictive accuracy. Okay, then of course you also have to invest, right? Okay. So this was now my first part to discuss a bit, say how we can understand the problems that machine learning ideas could fit well to. And I would like now to come to the validate thing. So we have a rough idea, we have identified a problem worth solving, but there are a lot of innovation risks now involved because we made a lot of assumptions. It's thoughts in our head, so we need to de-risk these ideas. And these, by the way, ideation and validation, they are iterative, of course. I don't say these are totally separated activities. However, they have served different purposes. So when we look at validation, the first thing one does today is you use one of the many canvases and template models that help you with a set of questions to sanity check your idea. And I've brought here two examples. On the left is a bit more technical one, the machine learning canvas developed by a researcher in machine learning that it's like a hands-on machine learning researcher. And I think it's very valuable if you have a machine learning team sitting there to sanity check if a solution is feasible. On the right-hand side, you see the AI canvas that was proposed by 3 Canadian business school professors. And notice the difference. So the left, the actual researcher calls it a machine learning canvas. The business school professors call it an AI canvas. Yeah, that's again the pattern. And on the right-hand side, this canvas, you can also fill in sanity check. Is there some data? What are we actually trying to do? What is the actions that are involved? What outcomes are we looking at? But I think it's more on a managerial level. So you could use it to, for example, show to a higher stakeholder what the idea is about. Or you could show him that his idea doesn't work quickly by using such a canvas. But of course, we have our own canvas. I will not show it today, but I will show the logic behind it. Another classical product management framework is this Venn diagram of usually depicting viability, desirability, and feasibility. Developed by IDEO design company, as far as I know, and the most used framework to structure innovation, I would say. And I appended it here by a fourth dimension, that is compliancy. Or yeah, let me quickly go through it. So the viability asks what is in for the company. The desirability asks, does the customer want it? So do we create value from it? Feasibility, can we build it? And now compliancy, is it just to build it? So are we allowed, more or less? Is it ethical? Is it correct? Is it right to build this thing? And I want to offer you here some checklist items that you can use to check if you should pursue the idea or maybe not, if you should invest further in it. Here, the no-brainer one is, of course, we want strategic alignment. So as I said, I think investing into own machine learning activities or own AI product development only pays off if it is really core to your business and if it has a certain stakeholder support to do so. The next thing that is quite not so clear is the value capture logic. So as I said, you might offer a prediction service, and there are several steps until this translates into actions and then outcomes and then value. But if you are forced to create value from it, be very specific about that. So if you cannot write down in 1 or 2 or 3 sentences what the value capture logic is, you don't have it, basically, right? And you have to investigate further. And it includes stuff like the business case and the KPIs you want to move with it. Desirability, also the first, the problem solution fit is classical. It's not related to AI. It's you need it for every product. So what is the job that the customer tries to get done that we want to help with? And we have to show solution proposals to the customer, to the user, and see if he or she understands it and can deal with it and accepts it. The more specific thing to AI products is this, again, understanding and trust. So are the users, can they live with probabilistic outcomes instead of a definite comment made by a product? This is not new. There is weather forecast, for example, since years, and everyone from us knows that there's a 50% chance of rain tomorrow, for example. What does that mean? Yeah, so we know about probabilistic outcomes and dealing with it, but let's say the advent of machine learning in so many other areas brings it to new application fields. So you're getting an uncertain parking prediction, for example. So how to do it, how to deal with it. And the second thing is, again, the opacity. So if this is a more critical decision and the users don't understand how the recommendation came about, they might not use it. And then the value, again, does not translate, does not realize at the end of the day. Okay, fourth dimension, feasibility. Of course, the biggest blocker to develop an AI product is the access of the data and the suitability of the data. So does it represent those patterns we need to develop the product? But also very important in practical product development is the serving infrastructure. So we have to operate and deploy the core product. That is one thing. Usually there is infrastructure that serves the model with data that at least we, for example, do not fully control in our company. That is, we have to check if there is a feasible way to build a data pipeline from the source data that we need to us and that it is stable and reliable. On the other hand, a machine learning team does not usually build user applications or front ends. So you have another dependency to the app team or the software team that will use your prediction and, for example, pass it on to the user or to the end customer. And these turn out to be sometimes the bigger bottlenecks that can kill or drive the costs of a project. And finally, there is the very important but not so cool aspect of compliancy. So whenever we work with data, we have to deal with privacy and licensing issues. So are we allowed to use the data in that way? There's also antitrust aspects when you share data or pool data across company boundaries. This could lead to cartel problems, and you have to mitigate that. So you have to check if you're, let's say, creating an unfair competitive advantage that is not accepted by the authority. Then there is company policies, that is IT standards and so on. That's also quite interesting. For example, in a bank, there's a strict split between production data that, for example, shows the true bank accounts of users, and test data that is completely mock data that you can use to test your software when you do software development. And the people that do the development of the product never have access to the production data, which makes absolutely no sense when you do a machine learning product, right? So the people that build the product have to have access to the real world data that has the privacy issues and so on and so forth. Otherwise, they cannot proceed. So you have to find a way, and if this is not in the IT standards of your company, in the IT process standards, you have to circumvent them or bring that in. I know this doesn't sound very innovative, but this is really the stuff that keeps you busy when you are in a bigger company and trying to get a machine learning product out. Another very, let's say, thing that you can think about is the accountability issue. So someone has to be accountable if something breaks or if something gets wrong. So who is accountable now? Is it the data scientist that developed the model from the data? Or is it the person that created the data? Because the data scientist will claim, yeah, I only detected the patterns that are in the data. So it's the fault of the data. And so this is not straightforward. So if you really have a business critical or legal critical application, find a way to deal with that. And finally, I think the last 2 points are quite well known. We also have to make an ethical check. The bias in your training data will carry over into the decisions your models make. And so we've seen it in HR data that have a gender bias. So not only because only in the past, mostly male employees got the pay raise or the, let's say, couldn't make it up to the management or whatever, it doesn't mean that this should be also the case in the future. Yeah, which could lead to a discrimination. And be prepared to think about that and have a framework to deal with it. That's, I would say, important advice. Okay, so that's the overview. It's classic. It's checklist work that you have to carry out, to get done, to make progress. If you only take one thing away from this, then please choose this one. So my claim here is that all these little checks and things can be handled at the end of the day. You can deal with them sooner or later. But what might really be a problem is the cost of data. So I would claim from an economics perspective, the viability of a machine learning product implies that the expected benefits, the total benefits, exceed the cost of data. The cost of data is the most important cost block. And yeah, let me elaborate a bit on that, because this is one of my key claims. Most people have also seen this Economist cover and have heard this claim that data is the new oil. It is essentially true. However, as most successes in machine learning or AI products have been achieved through supervised learning, it is labeled data that is the new oil. And I've brought this little graphic here to make that a bit more visual. On the right, you see again this my request response scheme. So if you remember the asset value forecast case I was mentioning, let's say we have a used car. It has a certain make, a certain age, and a certain color, and we want to know what might be the current value or the sales price of that car. That's the value proposition of the model. In order to produce that, we need training data that has those features and also correct labels. And that is, in that case, either we have observed sales prices for the similar cars, or we have very good expert evaluations of those cars. And we need a lot of them. So if you are in prediction and supervised learning settings, you could even say the cost of data are mainly driven by the cost of labeling. That is, for example, use cases need manual labeling by experts. Think of a radiologist checking medical images and trying to highlight anomalies in the organs or tissues. This is super highly skilled personnel that has to look at every entry of your data and come up with a label. It can be done, but it is costly. In other scenarios, you might need ground truth observation. So if you consider the parking case I was mentioning, if you really want to know how many cars were parked in a certain parking zone at that time of the day, you have to send someone to count them. Maybe you can use satellite pictures or something like that. I don't know, but it's then getting more expensive and more expensive. And the question is then again, so if we spend thousands of euros for market research agencies that sends people on the street to count cars, and use another fancy system that uses satellite sensors to detect free parking spots, is that cost bearable in the light of the value we can get out of this product, right? So there are, keep that in mind, and there are ways and that I find very interesting. I think it's one of the most valuable and practical research streams is that approaches to reduce the dependence on these perfectly labeled data, which you would call weakly supervised learning, where you only have noisy data that was crowdsourced and the algorithm tries to understand that, deal with that. You have transfer learning, where you have a pre-trained model that has seen a lot of pictures before. You only have to adapt it to your specific need. Or there's active learning, where the model more or less asks the expert only if it is uncertain about it. So you economize on the expert knowledge, I would say. It's getting even messier when we look at prescriptive use cases. Here I would say roughly that the cost of data are more or less equal to the cost of experimentation. So why is that? If you look at the request response scheme, it looks similar. So we have a description of a situation, and the response we expect is the recommendation. So do A or do B now. However, to come up with such a recommendation, we need training data that has seen certain states. So it has been in a certain context before, it has chosen an action and also observed a reward. So how good or bad turned it out to be. And creating this data is even more costly. So we need an experimental setup. We need to allow the machine to intervene. That is, we need to allow the machine to send product recommendations to our users. And we have to design a reward scheme and observe how good the machine is doing. And this adds up with the cost of exploration. That is, when you learn by trial and error, you have to exploit. That means you have to make errors to learn that it was wrong. So you're willingly allowing the machine to send some kinds of exotic or stupid recommendations to your user, only that it then can learn that it was not good and update the policy. This is something I think that most companies will not be practically involved with in the next year or two, but what people do in research is they use simulations, for example, in robotics cases, where you can simulate an environment with the physics of it, and the robot can learn to move in that environment. Or the most well-known case is self-play of games. So if you have heard about AlphaGo and this breakthrough that the Go playing machine won against Lee Sedol, this was possible because they created more or less some kind of synthetic data by letting the machine play against itself, right? But it's also a simulated environment, and playing games against itself in a virtual Go board does not cost a lot. It's cost of computation, But yeah. Okay, to sum up this, I would say there are a lot of extra costs of machine learning systems. We have the strong dependency on the right data. There's a higher risk of failure, higher costs for very specialized data scientists. Usually it's longer and more complex development operations and so on and so forth. So what we try to check is this cost of data that we do we have the cost of data in balance with the benefits, and are we really doing the critical accuracy improvement that makes us accept all this extra risks and so on and so forth. Okay. Part 3. I drink a sip of water. Let's say we found a product, we developed it, we validated it, and now we deployed it. So we have to maintain it, we have to keep it alive. We have to de-risk the operation of this product. And there's one thing that plays against us, and that's the general dynamics of the environment. So what you usually see is that a once trained model over time will have a depreciation or a decrease in performance. Why is that? Because the world is a dynamic system. It is not stationary, and customers' tastes change, or mobility patterns in cities change, and this leaves us with the burden that once we have the system out, we have always to be ready to refresh it, and we are always fighting against this depreciation of performance. So when you deploy it, you buy this, and you have to be ready to deal with it. The more simple case is that a simple refresh, retraining is enough. That's what I depicted here in the middle. So you just refresh, you leave everything the same, but you use the more recent data that came up in the last days and weeks to train a fresh version of the model and again increase the performance above your threshold. Sometimes this might not be sufficient, or for another reason you want to even improve the model, that is, even use different data or a new algorithm and so on. But what is important to know, I would think, is that you cannot just deploy it and let it go. It will degrade over time, and you will have to be ready to refresh it. This brings me to this picture. I copied it from a paper from Amazon employees about reference architecture, not how to come up with a machine learning system, but to operate it, to keep it fresh. And you see this messy picture here. So the model, or what I was showing there with my request response machine, is only the little part here below, the predictor. And the other part that coming up with a model is only the trainer. So all the other stuff here is machinery. You need to keep this system here alive and fresh. And you will basically constantly monitor the incoming data to see if it is similar to the data you have trained the model on, or if there are certain anomalies, for example. More importantly, you also have to constantly monitor the prediction performance to see if you are doing well and if you if your performance degrades. And let's say, okay, now you notice that something might go wrong, but you also have to be able to act, to intervene and to refresh your system. So you need further systems that allow you to deploy a new model to production, or to retrain in production your model, and so on and so forth. Which brings with it the burden to define thresholds, quality metrics, and so on, that are not determinable by algorithms. They are simply decisions and preferences you as a team and as a management have to contribute. So what kind of risks are we willing to take, and what accuracy level do we want to guarantee for our product, and so on and so forth. Okay, so I would like now even to move on. As you see, it's the more we're getting to operating stuff, the shorter the slides get. Oh, I noticed a little error. So this is meant to be the last separator, now looking at growing. Sorry for that. So how can we grow a product? I don't know is this Bremen, by the way? So it's a...
I think it's Hamburg.
Yeah. Okay. Oh no, what have I done? So let's look at the last part of this talk before I promise to summarize. It's how to grow your product. And what I brought is this picture here, because when you consider the efforts that it takes to connect data to your system and to build a data asset, and also the effort that it takes to create a model and deploy it and run it and keep it fresh, as we saw in the machine learning operations slide before. What this reintroduces the idea of asset utilization, I would say. This is one strategy that you should always follow is, once you have something out that works, you want to look for adjacent use cases. So can you leverage the data you managed to connect in the right quality as a constant stream and so on, to reuse it for further modeling? But especially once you established a good modeling approach, can you reuse this model asset and serve several use cases? I've written here these, proposed some definitions for what a data asset is and what a model asset is. The essence of it is, it's not a thing, it's more a capability. So I think we have to move away from this thinking that we have data, it's a static thing, we can analyze it and come to a conclusion. Data is a moving thing, it's a stream that is coming in, and the data asset is the capability to keep the stream alive, keep it fresh, monitor the quality, and pass it on. And the model asset is the capability to keep the model fresh and constantly predict or prescribe in a good quality, repeatably, scalably, and so on and so forth. And as this is difficult to build, you want to look for these adjacent use cases. So one example from our company is the asset valuation again. One critical data source we have is our own used car sales. So let's say some percentage of the used cars we get back from leasing contracts, we sell them on the used car market. So we can directly observe the income, the price we were achieving with it. And this is a key data asset. And it turned out that there are at least 3 use cases for that. So one is to make this long-time forecasts, as I said, what is the residual value of an asset within 3 years? So that's the 3-year forecast. But on the other hand, this is residual value management, as you call it. There's also residual value risk management. It's another department that constantly looks at what is the cars we have in our books and how are their market values behaving over time. So do we compile risk in our portfolio of cars or not? And they need the same thing, but only in a different prediction horizon. So they don't need a 3-year forecast, but a shorter forecast or multiple forecasts. And further, there are also applications in customer relationship management, where sometimes a specific curve of depreciation allows you to make special offers to some customers, for example. And to not build things from scratch again, you should really aim to invest in those assets that are core to your business and then leverage them, increase the utilization by multiple users. Okay, so let me summarize. Last slide. So we've seen this for activity type grid. Now I changed the text inside. So if I boil it down to one key recommendation, so if you are in the first, in the ideation phase, what are you looking for? You're looking for these things that need a complex tasks or problems that need a complex mapping and that are core to your business. I think these are the two guidelines for quickly assessing if the problem is suitable. If you want to validate if this is a very good idea to build a data product for it, you have to check if the expected benefits of that system would exceed the cost of the data that you have to bear. If you manage to deploy the system, you have to maintain and you have to master the machine learning operations game. So machine learning operations, or ML ops, is a hot topic now, how to keep the systems alive and how to refresh them. So you need this capability and you need to build it up. And finally, I recommend to grow your products by increasing not only model asset utilization, but also the data asset utilization. That would increase the return by you share the costs for the data pipelines, you share the costs for the model, but you have non-rivalry in use. So you can, it doesn't hurt you to accept further use cases. Okay, so that's it. So far, I think there is room for questions or discussion. Please help me here from the moderation team.
Yes.
I would hope for that because, yeah, I'm looking for your opinions and your input also to this little framework.
Yeah, thank you very much, Michael, for this very illuminating talk. And I would open the floor now to everyone. I will stop the recording so you feel more comfortable in asking questions.